Hi class, welcome back. We're going to be starting Unit 2 today, which is our quadratic equations unit. So we're going to start off with lesson number 1, which is introduction to these quadratic functions. If you remember last year, you did have a little bit of introduction to quadratics, but we're just going to be going over just a few things from last year as well, just to get everyone right on the same page. So by the end of this lesson, the things that you should be able to know are the degree of the function. You should know the equation of a quadratic function in standard and vertex form. You'll know how to graph a quadratic function, and you'll know how to find the first and second differences to determine if a function is linear, quadratic, or nonlinear. So we're just going to get started off by doing a little bit of an introduction to what is a quadratic function, as well as what does it mean by when we say what's the degree of a function. So if we figure out what the degree of a function is, it's just defined here, but we'll start off with, quadratic function. A quadratic function is an algebraic expression that contains an x squared and no other item of a higher degree or other term of a higher degree. So when we say degree, what we actually mean is that there is no term that has an exponent higher than 2, because that's what degree represents, higher than 2. So for example, if it was an x squared plus 2x plus c, that's a quadratic function. But if I had x cubed plus 2x squared plus 3, even though there's a 2x squared in there, the x cubed is actually higher than the 2x squared, so then those two will not be a quadratic function. That will actually be a function with the degree of 3. So when we talk about what does it mean to be a degree of a function, a degree of a polynomial function is the greatest exponent on the equation. So the largest exponent in there, just like I said, with x cubed, it would be 3, x to the power 4, it would be it would be 4, and so on and so forth. So you go in, you look at what the highest exponent in it is, and that's the degree of your function. Kind of like when you tell people what your degrees are, like I'm not going to tell people that I have a high school diploma if I have a master's degree. So just similar, you always go with the highest number. Every quadratic function has an equation that can be written in this general expression, where it's y equals ax plus bx plus c, where a, b, and c are constant numbers. So normally it would be written something like y equals 2x squared plus 4x plus 8. Right? That's an equation, that's an example of what an equation would be written like. Notice how here your highest exponent is going to always be x squared. That's important to remember. That's how we know that this is a quadratic equation, because the highest degree is 2. Okay? So when we're graphing quadratic functions, they kind of have a standard shape, and it's called a parabola. So it looks kind of like this U with little arrows at the end, right? And in this parabola, there's a few things that are really important for us to remember. So the first thing is called the axis of symmetry. So the axis of symmetry is a line that divides the parabola into two mirrored branches, such that they're a reflection of each other. So if we took the axis of symmetry and kind of folded the parabola along it, then that would mean that we have the same. Like you could just fold it in half. So it looks something like this. So the axis of symmetry, or the AOS, as later on we'll call it, is just when we cut this right in half. That's the axis of symmetry. The vertex, also known as the turning point, is where the parabola changes direction. So the vertex is the point where the parabola intersects with the axis of symmetry. So you'll notice it. I'm just going to go in and draw this right here. So we got this parabola. Our vertex is right here, right? So you notice that it's coming down, and then it's starting to go up. So it's where the parabola changes its direction. Also, if you notice, this is our axis of symmetry, and that's where they kind of intersect. It's either a maximum or a minimum point. So a minimum point would be if, say, this parabola was actually upside down, right? In this situation, it's the minimum number that it can be. In this situation, it's the maximum number it can be. Okay? And then the direction of opening, also known as concavity, is the direction in which it opens. So you'll notice here, this parabola opens up. and this parabola opens down. And when we talk about transformations, why something might have a different axis of symmetry, why something might open upwards and open downwards, have different max and different min, we'll talk about that. Okay, so as we move forward, so the ax squared plus bx plus c is a standard form. The other form that we write our general equation is y equals a bracket x minus h bracket squared plus k, like it's written here. And if you want a good comparison, if you remember back in grade 9 when we learned about y equals mx plus b, y equals mx plus b was our slope point form, which is the same as saying it's our vertex form. It's very similar. Y equals mx plus b just gave you more information about the graph than our standard form of the line, which was the 0 equals 2x plus 3 plus whatever it might have been, right? Or so, sorry, 2x plus 3y plus 1. So just remembering back, if we're going to compare them, we have our standard form of the line, which is what I showed you before, and then we have our vertex form. Vertex form is often the one that we use to graph just because it gives us a lot more information. It gives us the stretch, it gives us the shifts, it gives us what it's going to look like overall. And as we go through it, you'll know more about what A means, what H means, and what K means. And how those impact the shape and the positioning of the graph. So before we even get started, let's go back to grade 9 and learn how to graph stuff again, right? So if we're thinking of grade 9, how do we graph stuff? If I'm given an equation like this, where I'm given y equals x squared, it becomes really easy. I personally, whenever I make graphs, always use these points. I always use at least 3 negative numbers. I like to have 0, and I like to use at least 3 positive numbers, and it just makes the most sense if they're like corresponding values, if they're going up by 1 or up by 2, right? Keep the interval between x the same always. It'll just make your graph easier and it'll make it look nicer, right? So if I'm going to go up by 1 on x, just always go up by 1. So go, okay, plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. Right? Just makes it easier for me to graph. You could also do plus 2, plus 2, plus 2. Just make sure it's consistent, the intervals in between those x's. So let's just get started. Here we have negative 3. If I want to find the corresponding x value, I'm just going to go in and say, okay, y equals x squared. So I'm going to plug in negative 3 for x. That means that y is going to be equal to negative 3 squared, which is 9. And I'm just going to continue to do the same thing for everything else. As you go down the graph, you just plug in another number. So you have x here is negative 2, so I plug in negative 2 for x, and so now I know that negative 2 squared is going to be 4, right? Y equals negative 1 squared equals 1, y equals 0 squared, and make sure it's always in brackets. And that's because if you didn't have negative 3 in brackets and you put it into your calculator, you'd actually get negative 9, and that's not correct. So just for good form, and this is where form impacts the number you get, just make sure you always have it in brackets. And then you have y equals 1 squared equals 1, y equals 2 squared equals 4, and then y equals 3 squared equals 9. Notice how nothing's negative, and that's because our negative values, when we square two negatives, when we multiply two negatives together, they give us a positive. When we square a negative, it's the same thing as multiplying two negatives, so we get a positive as well. So just going to go here and say, all right, so negative 3, and I'm just going to go on to my graph, and I'm going to find negative 3 on the x-axis and go all the way up to positive 9. I'm just going to go plot my points in. Negative 2 is at 4. Negative 1 is at 1. 0, 0. 1 goes to 1. 2 is up at 4. And then 3 is up at 9. And then I'm just going to go in and draw this curved parabola shape here. And that is what my graph looks like. If I had to go in and find the axis of symmetry, right? The point at which it turns around is at 0, so it's just through the x-axis. That's my, or the y-axis. That is my axis of symmetry, right? If I was asked what's your minimum or maximum, my minimum point is going to be 0, is 0, 0 is the minimum, right? And if I asked what direction does this open, this parabola opens upwards, right? Because it's pointing up. Okay, and that's how you plot that. So moving forward, let's try one that's a little bit more complicated. So I know that it's going to be positive, so I just cut off the bottom part because I didn't necessarily feel like it was important to keep that there. But you can keep that there if you want to. So let's try this one. It says that x, I didn't give you a bunch of x's already, and then I gave you a little bit more complicated of a problem, or of a y equals function. So try doing these by yourself, and then try plotting them on the graph. I like to start off, I'm going to say what I started this off with. I started off with -2, and that's just because I know I'm only going up to 10. So when I did the math, right, like I knew that if I did anything over -1, I was going to get higher than 9. So that's just how I started this. Like the way that I made the graph was like that, but you can start wherever you want. Okay, so I'll let you go through and do this one on your own. So just pause the video here and try to solve it on your own, and then we can take it up together. Okay? So hopefully you pause the video and now you're just waiting for me to take it up. So here we have x's. So I started with -2, like I said. That's just the number I decided to go with. I actually don't even plot -2. I actually plot it from -1, but you'll see why. So let's just go in and write in what I have. So always put your stuff in brackets. So it's going to be -2 minus 2 squared, right? So if I do -2 minus 2, you always do what's in the brackets first. I'm going to get -4, and -4 squared is just going to be 16, right? Same idea. I'm just going to continue and do the same thing. So now I have -1 minus 2, right? -1 minus 2 is going to be -3, and -3 squared is 9, right? Y equals 0 minus 2 squared. 0 minus 2 is -2, squared is 4. Y is equal to 1 minus, and I was, sorry, brackets. 1 minus 2 is going to give me -1. So that's -1 squared, which is 1, right? Now I have 2 minus 2, which is going to be 0 squared. And 0 squared is just 0. Y equals, and please have better form than I have, because sometimes I get lazy. So 3 minus 2 is going to be 1 squared, which is going to be 1. And then y equals 4 minus 2, which is 2. Squared is 4. So now I have my values. This is what I was saying, is that I'm not even going to graph that one because it's 16 and it's off my grid. So I'm just going to start off at -1. So I know -1 is going to be positive 9. I know that 0 is going to rest at 4. I know that 1 is going to rest at 1. Right? 2 is going to be 0. Then it comes back up. And then 4 goes up to 4. And I can just assume, and I'm going to write in 5. So if I did 5 minus 2 squared is equal to, 5 minus 2 is just 3, is equal to 9. So I'm just going to go put in that 9, because I like to have a nice parabola looking shape. So I'm going to go up to 5, and it's going to be 9. Right, and my parabola is going to look like that. Otherwise, it would be incomplete, and I don't like that. Right? So that's my parabola. And then if I go in, now my axis of symmetry is actually shifted over by 2. And we'll talk about this. when we talk about horizontal shifts, right? You'll notice that the graph is just kind of shifted over by 2. We'll talk about that and how that happens. We'll notice that my minimum now, right? I still have a minimum. My minimum is at 0.20 now, and it's still opened upwards, which is why I have a minimum value. Okay? So that's just how to graph those. Moving on, we're going to move on to something called finite differences, right? So finite differences are determining if a relationship is linear, quadratic, or neither, right? So before we go on to determining whether it's linear, quadratic, or neither, you need to know what a finite difference is. A finite difference is the difference found between y values in a table with evenly spaced x values. And the most important part here is evenly spaced x values. Remember when I said you can go up by however much you want. You can make your x's whatever you want. Just make sure that they're evenly spaced out. So if you're going to go up by 2, always go up by 2. If you're going to go up by 3, always go up by 3. If you're going to go up by 1, always go up by 1. That's the reason. It's because it makes first differences easier to find. First differences are the differences between consecutive y values, and second differences, if the x's are evenly spaced out, and the second differences are the differences between consecutive first differences, then third differences would be consecutive second differences, and so on and so forth. An important thing to remember is if first differences are the same, then the function is linear, right? If second differences are the same, then the function is quadratic, and if they're different, it's neither. When you go on to learn more about different types of functions, when we do exponential functions, you'll see how we can use this information to find what type of function it is, if it's quadratic, so on and so forth, right? So example, if a relationship is linear, quadratic, determine if a relationship is linear, quadratic, or should be neither, sorry y'all. This should be neither. Neither, using the function above. So let's just go in and write our x's from the function above. I'm not going to scroll back and forth. I just put them up on my chart over here. But for our purposes, I'm going to start over at negative 1x, because that's the one we graphed, right? So 1, 0, 1, 2, 3, 4, 5, right? And then let's just put in our y value. So I have 9, I have 4, I have 1, 0, 1, 4, 9, right? And we're just going to go in and find our differences. So in order to find first differences, first things first, our x is evenly spaced. I'm adding 1 here, I'm adding 1 here, I'm adding 1 here, and I'm adding 1 for all of them. So yes, so we can now determine our first differences given this scale. Then I go and say, okay, I got to do y2 minus y1. So y2 minus y1, which is the same thing as saying 4 minus 9, and in this case 4 minus 9 is negative 5. Same thing, 1 minus 4, which is going to give us negative 3. Then I'm going to do 0 minus 1, which is going to give us negative 1. 1 minus 0, which is going to give me 1. 4 minus 1, which is going to give me 3. And then 9 minus 4, which is going to give me 5. That's how I find the first differences. Notice how the first differences are all different. So this is not a linear equation. These are first differences are not constant, right? Let's look and try to find our second differences now. So I'm going to do this in pink. So I'm going to do negative 3 minus 5. Same thing, it's just now you're negative 3 minus negative 5, right? And be careful because this turns into a positive. So it becomes negative 3 plus 5, which is 2. Negative 1 minus negative 3, which is the same thing as saying negative 1 plus 3, which is 2. 1 minus negative 1. And it's always down, then to the top. 1 minus negative 1, which is 2. 3 minus 1, which is also 2. 5 minus 3, which is also 2. Notice how these differences are constant, right? You have negative 2, negative 2, negative 2. I'm sorry, positive 2, positive 2, positive 2. That is what we're going to use, and therefore the second difference is our constant, so this is a quadratic function. Okay. So we're just going to do a few practice problems here. I'm going to ask you to find whether or not it's linear, quadratic, or neither, right? I want you to pause this video here and go through this by yourself and then just take it up with me so that you understand where and how we're finding out if things are quadratic or not. Okay, so these are examples for you to try on your own for homework, and then we'll take them up together. All right, so hopefully you've paused it on your own, and we're just going to take them up. So here we're just going to go in and say, okay, 8 minus 18 is going to be negative 10. And I'm not going to always write it in. I'm just going to start doing it. 2 minus 8 is negative 6. 0 minus 2 is negative 2. 2 minus 0 is 2. 8 minus 2 is 4. 18 minus 8 is 10. First differences are not constant, so we know this isn't a linear equation. Let's try to figure out if it is a quadratic. Negative 6 minus negative 10 is 4. Negative 2 minus negative 6 is also 4. 2 minus negative 2, 4. 4 minus 2, this should be 6. 8 minus 2 is 6, sorry. 6 minus 2 is 4. 10 minus 6 is 4. My differences here are constant, therefore I know that this is a quadratic equation. So I'm going to write quadratic. Second differences are constant. Okay, let's go on. Here we know our x's are all this going up by 1, so we can actually do this, right? Negative 2 minus negative 3 is 1. Negative 1 minus negative 2 is 1. 0 minus negative 1 is 1. 1 minus 0, 1. 2 minus 1, 1. 3 minus 2 is 1. Notice how our first differences are constant. Let's just, for the sake of clarity, go and try doing our second differences. 1 minus 1 is 0. 1 minus 1, 0. 1 minus 1, 0. 0, right? So I know that this is a linear function because first differences are constant. You don't need to go in and actually write those zeros. I'm just showing you that if you were to find second differences, they would be 0. Okay. Let's move on to our next one. Right here we have a function. So let's just go in. We're going to do 0.25 minus 0.125, and that's going to give me 0.125. 0.5 minus 0.25 is going to give me 0.25. 1 minus half is going to give me 0.5. 2 minus 1 is 1. 4 minus 2 is 2. 8 minus 4 is 4. Right? Let's go on and try our second differences now. 0.25 minus 0.125 is going to also be 0.125. I'm just going to do the math here. 1 minus half is half. 2 minus 1 is 1. 4 minus 2 is 2. The first differences aren't constant. The second differences are constant, so this is neither. First and second differences, not constant. Okay? And then, just moving on, we're going to go here. We have 3 minus 8, which is going to be negative 5. 0 minus 3, which is going to be negative 3. negative 1 minus 0, which is going to be negative 1, 0 minus negative 1, which is going to be positive 1, 3 minus 0, 3, 8 minus 3, 5. And then we're left with 2. Sorry, I'm just going to change the colors because I've been doing that. Negative 3 minus negative 5 is 2. I think this is honestly very similar to the first one that we had. 2, 2, 2, 2. So then we know our second differences are constant, so this is a quadratic equation. Okay. And then we have these at the bottom. This, we have to look back at degree, right? So let's look at what's the highest degree of this equation. So we have a degree of 2 here, and we have a degree of 0 here, because anything to the power of 0 is going to give us 1. So we know that in this situation, this is a quadratic equation because it has a degree of 2. Quadratic, it has a degree of 2. Okay, moving forward, let's look at this. We have a 3, we have a 2. So because we have a 3, we don't really care about this 2, we don't care about this 1, and we don't care about this 1, right? This is not quadratic. Or linear. It has a degree of 3. Right? So it has a degree higher than 2 or 1, so it's not quadratic. This one has a degree of 1, and if you remember, this is y equals mx plus b, so this is linear. Right? Linear equations have a degree of 1. And then here we have a degree of x. So since the degree isn't 1 or 2 or 3 or anything, this isn't a quadratic equation either. So we're just going to leave it as neither. Neither degree is x, right? We don't know what the degree is. It changes. And we'll talk about what type of equation this is later when we talk about exponential functions. Okay? And that is it for this lesson. So thank you for watching. Try doing the homework problems from the workbook. I'll post them onto Google Classroom, and you can just go and access them there. Thank you.